Okay, we are still doing things with circles, and we're going to do a couple different things in this example, and then that'll give you some just knowledge for how you keep going with circles. So this little example 4, if you're in my class, you should notice that I skipped example 3. That's because I want you to try that one on your own. So it says when you make a call on your cell phone, which almost nobody does anymore, but when you do, a tower receives your signal and transmits your call. And when you drop a call, that's because you walked out of a cell tower's radius. Like you're not in the radius of the circle to pick up and transmit your call anymore, and you haven't entered a new one. So the way cell phone towers work, like here would be a cell phone tower, here would be a cell phone tower. Each one has a radius that they pick up. And so if you're on the phone, here's you, and you walk out of this circle, when you're in here, that's when you have no signal and you can't call anyone. Because this tower hasn't picked you up yet. You're not in that radius. So that's what happens when a call is dropped. So a way to monitor the range of a cell tower is to use equations of circles. It says, suppose the equation of a circle is x minus 7 squared plus y plus 2 squared equals 64. And that represents the position and the translation of the cell tower. It says, where is the center? What is the radius? And graph the circle. So I'm going to recopy this equation of the circle first. X minus 7 squared plus y plus 2 squared equals 64. And right under that, I'm going to write the generic equation of a circle, just so we have that for our reference, because it might be helpful. So the first question is, what's the center? And the center you find from looking at the h and the k. So from our equation to the original equation, or actually, let's think of it, what did we have to plug into the generic equation to get to our equation? Well, let's take a look at what's different. We have x and x, so that's the same. We have minus and minus, so that's the same. So the only thing that changed from h to 7 is we plugged in a 7 for h, not a negative 7, because the minus is part of the equation, right? We just took out h and put in a 7. So that means the x-coordinate of my center is going to be 7. And then we're going to keep going. We have a plus sign, we have a y, and then in our original equation, we have a minus 2. In our equation, we have a in the generic equation, we have a minus k. In our equation, we have a plus 2. So to get this minus to change to a plus means we had to plug in a negative 2. Because remember, if you do minus a negative, that's the same as a plus. So the center is at 7, negative 2. So we did, where's the center? Okay. Now it says, what's the radius? So this number at the end is r squared. So r squared is 64, which is fine, but it doesn't ask us for r squared, it asks us for r. And we've done this a lot in class. How do you undo a square? You square root it. So r will be whatever the square root of 64 is. It happens to be 8. So the radius is 8. This gives us all the important information we need to do the third part, which is graph the circle. So we're going to have a center at 7, negative 2, and a radius of 8. So I gave you this graph. I'm going to add my own x and y axis to it. And let's see, you have to be able to go left, right, up, and down 8 from your starting place. So I think I'm going to kind of put this maybe in the middle. It might go off the graph a little bit. We'll see. I don't know for sure. Okay, so now, so there's my x and y axis. Now I'm going to plot this point, 7, negative 2. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, and then down 2. So there's the center of my circle. And now the best way I know to graph a circle is start at the center and go up the number your radius says. So our radius is 8. So start at the center and count up 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh gosh, guys, this is going to go off the graph. Sorry. And then go back to the center and go to the left, your radius numbers. Now we're going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a big circle. If you positioned your X and Y axis differently than mine, this might not go off the graph if you have this on paper. If you do, it's fine. Or if it does, it's fine. So now we're going to go back to the center, and now we're going to count down 8. So let's see. 1, 2, 3, 4, 5, 6. Uh-oh. Let's see. Okay, let's try this. 1, 2, 3, 4, 5, 6, 7, 8. I'm just kind of estimating where it would be if I had more of a graph down there. And then finally go back to the center and count to the right, your radius number. So we're going to go right 8. 1, 2, 3, 4, 5, 6, 7, 8-ish. And then you're going to connect all of these dots in the best kind of circular way you can. It might wind up looking a little more like a diamond. This is just a rough sketch. It's fine. Okay, so now we have a circle that fits this word problem we were talking about and has a center 7, -2, and a radius 8.